Hi, welcome back. Today we're going to start Chapter 7, which is the beginning of our trigonometry units. So this section is the introduction to radian and degree measure. So we're going to go over some things that hopefully you already know, and then we'll kind of put it all together and make sure that we're good to go for the remaining sections in this chapter. All right, so this page is just a lot of definitions that hopefully you remember from high school days, but let's go over that anyway. So we're talking about an angle, okay? There's a couple of things in trig that stand out. So one is that you know where the vertex is, and that basically is the common endpoint shared by two rays. So right here would be the vertex of this angle. Okay. Then you have the initial side. So this is a little different in trig. In trig, we rotate the angle, and it's a specific direction that you rotate it on whether or not the angle is positive or negative. So you always have the initial side, okay? And that's the basic starting point of your ray. So this is the ray that we're going to start with. So we'll call that the initial ray, okay? And in trig, it's always going to be the horizontal one, okay? So this would be the initial side over here. And then the terminal side is what we call the rotated ray. So basically you're starting here and then you're going to rotate up or down a certain amount. So when you rotate up, I'm going to put an arrow here to show that I started at the initial side and went up this way, then this would be considered the terminal side. Okay? Now, that right there is a positive angle. So positive angles move counterclockwise from the initial side. Okay? So think about if you had an XY axis, if this is on the x-axis and you're going into the first quadrant. So that's how you know that that's going to be the positive angles. Then a negative angle would move clockwise from the initial side. Okay, so down underneath there's another example of a positive angle. Here's the horizontal and it goes up. And notice the negative angle. Here's the initial side. It's the horizontal side, and then we're going to rotate it down. That would be a negative angle. So some of you haven't dealt with negative angles before, but that's how they work in trigonometry. All right, so now, after we have the rotating of this angle, we then put that angle in what we call standard position. Okay, and standard position is when the vertex of an angle is positioned at the origin, at that point 0, 0 of the coordinate plane, and the initial side is always the positive x-axis. So there's a lot of words here, so I just want to make sure you understand. Here's the vertex at the origin, and this is the initial side, okay? So when you draw angles in trig, you always start at the initial side, which is the positive x-axis, and then you're going to rotate this way to be a positive angle. So this would be the positive angle. Here's the terminal side. Or we could draw the same angle going this way. We'd have to draw it a little farther, but that would be a negative angle on this side. Okay? The degrees would be different on those, which we'll talk about in just a minute. Okay, all right, so that's standard position. That's real important because we're going to do a lot of stuff in standard position. All right, then this stuff is pretty much review for you, but let's go over what all these are called. So the degree measure, a degree or one rotation around the circle is equal to 360 degrees. So 1 degree is a very small unit, so it takes 360 1-degree angles to make one rotation around the circle. Then you learned about different size angles. So you have an acute angle, which is an angle between 0 degrees and 90. You have a right angle, which is exactly 90. You have obtuse angles, which is between 90 and 180. Then some of these might be new, but then you have what are called quadrantal angles. Those are angles whose terminal side lies on I'm going to say the X or Y axis, okay? So if the terminal side lies on an axis, then those are quadrantal. And then you have a straight angle, which is exactly 180 degrees, okay? Now, in trig, we can go way above 180 degrees for an angle. We can go above 360 degrees. And as you just learned, we can also have negative angles. So that's kind of a new twist on the angle thing, because typically angles you draw or are used to are always positive. And they're never bigger than 180 degrees. Okay? All right. So keep that in mind as we move forward. So we're going to start by drawing some angles because you need to be able to sketch an angle, and that includes rotating it the correct way. All right, so we're going to sketch these following angles in standard position. So for every angle, when you start, if you're asked to draw it in standard position, here is the coordinate plane. The initial side will always be on the positive x-axis, okay, always. So for every one of these, that is how you start. Now, positive 90, we would go up, and 90 degrees would end up right here. And I have to put an arrow there showing that I'm rotating it counterclockwise so that it's positive. So that's 90 degrees right there, positive 90 degrees. All right, now, B is a negative 45 degrees. So again, for every problem, you start on this side right here. And now we're going to go clockwise 45 degrees. Well, 45 degrees is halfway between 90 and 0. So I'm going to just sketch about here. And notice I'm going to put the arrow going down. That represents a negative angle. So there's your negative 45 degree angle. Okay, so the measure is still 45 degrees, but because we went down clockwise, that's why it's negative. So that makes a big difference. So you guys have to put this little arc and you have to put those arrows. Otherwise, it's going to be considered wrong. All right, the next one is a positive 120 degrees. So again, here's your XY axis. We always start at the initial side being over here on the positive x-axis. 120 degrees would be 90 plus 30, so about here. And again, we're just sketching. So we would draw the arrow this way to represent a positive 120 degrees. All right, next is 400. So that's bigger than 360. So let's see how that works. All right, so we know we're going to start here. Okay, so think about 400. I'm going to go counterclockwise, but if I go all the way around the circle once, that's only 360 degrees. So then I got to go up another 40 degrees, right? Somewhere in here. Now, I can't just draw an arrow right there because that would represent 40 degrees if I just went from here up. So you have to show that you did an extra rotation. So you would start at the initial side and you would do what you did. You went around to 360 and then up 40 more. Okay? So even though this angle would look exactly the same as a 40 degree angle, the difference would be that you have that extra rotation in your diagram. That's how I know that you know where 400 degrees is. Okay? All right, and then we got one last one, negative 370 degrees. So again, we're going to start here, initial side. Now we're doing negative, so we have to go this way. But again, if we go all the way around the circle, that's only 360. So we got to go 10 more degrees. So right about there. And I can't just draw it like that because that would be a 10 degree angle. So I'm going to go all the way around the circle and then the arrow. So that shows that it's a negative angle, okay, negative 370. But it shows how I went around more than once. Okay. Some of you have a hard time with this and kind of being able to pick out these angles, so just make sure you practice that, okay? All right, now, here's the thing. We just did multiple angles that went around the circle more than once. So I want you to notice what happens when we draw these three angles. Okay, so we're going to sketch these three angles on these three different coordinate planes, and look what happens. So first is 60 degrees. So if we sketch 60 degrees, we would go up 60 degrees that way. Okay, there's 60 degrees. If we draw negative 300 degrees, okay, think about that. Negative 300 would be 90, 180, 270, and then 30 more degrees, right? Because all the way around would be 360. So I'm going to be 60 degrees less. So it would go this way. So there's negative 300 degrees. And then I'm going to do 420 degrees. So again, starting at the initial side, we're going to go counterclockwise. Once around would be 360. And then to get to 420, I would have to add another 60. Okay, so there's 420 degrees. So what do you notice about the terminal side on these is they're all in the same place. They're all 60 degrees away from the x-axis, right? This is 60 degrees right here. From here to here is 60 degrees, and from here to here is 60 degrees. So these terminal sides are all the same. Okay, they're in the exact same location. They're in the same location, okay, which is 60 degrees away from the positive x-axis. Okay, that's important because when you have angles that end up like that, where the terminal sides are the same, those have a special name. They're called coterminal angles. Okay? So what do you notice about coterminal angles? Hopefully you'll see that they differ by 360 degrees, whether you add or subtract. Okay, so for example, if you take 60 minus 360, you end up at negative 300. If you take 60 plus 360, you end up at 420. So every time you go another 360 degrees forward or backward, you're going to always end up in the same location that you started with. So those are called coterminal angles. So down underneath here, and I kind of took away, so your notes don't have this line because I didn't, this is a new book we're using, so that's not in your new book. So just disregard what I crossed out there. So coterminal angles are angles that are in standard position having the same terminal side. Okay, so there's lots of them. And to find a coterminal angle, again, it's very simple. You just either add 360 or subtract 360, and you can do that as many times as you want. So in number 3, it says find one positive and one negative coterminal angle. Okay, so your angle, theta, and in trig we use Greek letters a lot to represent angles, so that's theta. So to find one more positive one, we would take 215 and add 360. Okay, so, and it doesn't really matter. You could add 720. That would still be a coterminal angle. Okay, so as long as it's a multiple of 360, it would work. So we'll just do it one time. So that's 575 degrees. So if we drew 215 and we drew 575, their terminal side would end up in the exact same spot. One negative coterminal angle, well, to get to the negative numbers, I'm going to subtract 360. Okay, so again, you can keep subtracting and keep subtracting 360 a bunch of times, but we'll just do it once. So negative 145 would also be in the exact same position as 215. Okay? All right, so coterminal angles are easy to find. You just, again, multiples of 360. All right, now, again, on your notes, you have a little bit different definition. So I had already started these and I didn't want to print out another one. So your definition of radian is a little different. I tried to write mine as much, but we'll talk about that in a minute. But first off, a radian measure. So in high school, most everything you guys did, unless you took some trig or calculus, your angles were always in degrees. Well, there's another unit of measure that measures angles, and those are called radians. That's what we use in trig. okay? So we're going to use those in trig a whole lot more than degrees. We'll use both. I'm trying to focus. It looked a little out of focus for me. There we go. All right, so one rotation around the circle. So if I start here and I go all the way around the circle, remember in degrees that was 360. In radians, it's equal to 2 pi. Okay, now we use pi a lot in trig because writing the decimal of that is, obviously it's an irrational number and the decimal goes on forever. So this is an exact way to write it. When you take 2 times 3.14 and get 6.28, that is incorrect, 6.28, okay? That's just an approximation because pi obviously is more than, right, the decimal goes out more than 3.14. So instead of writing a bunch of decimals in trig, we usually just leave pi in our answers because it makes it a little simpler to write, okay? But you got to understand that pi is just a number and it, they're decimal numbers, okay? All right, so then what's a little different in your definition, but it's still the same? 1 radian. How do you know the length of 1 radian? Okay, so you think about it. If it takes a little more than 6 radians to go around the circle, then how did they come up with a radian? So it's a very specific number and a measurement, but 1 radian is the measure of the arc length, which is the outside of the circle, part of the circle. That measurement would equal the length of the radius in the angle that you have on this circle, okay? So whatever the length of the radius is on your circle, that's 1 radian, okay? So if you take 1 radian, so this is 1 radian right here, 1r, okay? From here to here, if I do that again, so about the same length, I'm estimating here, but that's about the same size, right? So there's another radian. And then I would do it again. Okay, so there's another radian. Now think about it. All the way around the circle is 2 pi, right? All the way around the circle from start. If I start here, I'm at 0 radians. And if I go around one whole time, I'm now at 2 pi. So if I only go halfway around the circle, hopefully you would agree that that's 1 pi. So this number, halfway around the circle, that measurement, if I measure the outside of the circle, I will get 3.14. So if this is 3.14 to right here, then obviously 3 radians would be just a little shy of that, right? This is 0.14 in here. All right, so then again, if I do it again, I go right about here. If I do what's 1, 2, 3, so there's 4 radians. If I go again, I'll get 5 radians. Trying to be a little bit longer. 5 radians. And then 6 radians would stop. Again, a little bit short because all the way around the circle is 6.28, right? 2 pi. But that's what a radian is. So you got to keep that in mind. The measure of 1 radian is the length of the radius. If you had a piece of string and measured it, that's what a radian would be. So it doesn't matter how big the circle is, 1 radian is always going to end, it's always going to take 6.28 pieces of string if you measure any radius. That's why the circumference is always the same in all your measurements on circles, because they have a very strict relationship, so that's never going to change. Okay? All right, so on number 4, we're going to do some labeling. So it says, on the circle above, mark the locations for pi radians, 2 pi radians, which we've already done, pi over 2 radians, and pi over 4 radians. All right, well, if halfway around the circle is 1 pi, then 90 degrees would be pi over 2, or half a pi, right? So we call that pi over 2. You can say 1/2 a pi, but you're going to see it written as pi over 2. Okay, so this is all the way, halfway around the circle is 1 pi, which is 180 degrees. And then 90 degrees would be 1/2 a pi, which we write pi over 2. Well, then pi over 4 is half of pi over 2. So pi over 4 would be 45 degree angle. So somewhere right about here, the halfway point, that would be pi over 4. Okay, so that's your 45-degree angle. So you need to start learning the radians, and you need to know that 45 degrees and pi over 4 are the same thing. So remember, it's the measure of the angle, but if you know the measure of the arc length, that is the same thing as the central angle, if you learn that in geometry. So in degrees, we're kind of looking at this, 45 degrees, but with radians, we're looking at the measure of this, which is pi over 4. They are one and the same. Okay. All right, and then underneath there, let me make this a little smaller. All right, so then underneath that it says, then mark the location for 1, 2, 3, 4, 5, 6 radians. So we did that. So remember, it's the length. So this right here would be 1 radian. Right here would be 2 radians. A little before pi would be 3 radians. Down here would be 4 radians. Where the 5th one ended would be 5, and then 6 radians, remember, would be a little bit less than 2 pi, which is 6.28. So you might be asked, what quadrant is 3 radians in? What quadrant is 5 radians in? So you need to remember, not every radian has to have the pi with it, okay? Pi is just a number. It's just a clean way to write it. So 3 is also a radian. It's just because it's a whole number, I don't need to put pi in it because that's not part of it, okay? All right, so we'll practice with radians as we move on, but you need to kind of keep that in mind and start learning these. All right, so we need to sketch each of these angles below in standard position. So 3 pi over 4. Think about where that would be. 3 pi over 4 on here. If this is 1 pi, then 3/4 pi would be right here. Right, so that would be 90 plus 45. That's a 135-degree angle. So 3 pi over 4 would start here, and it would end up right there, 3/4 of the way around to pi. So there is a positive 3 pi over 4. Same thing as 135 degrees. Okay? All right. 3 pi over 2. 3 pi over 2, that's the same thing as 1.5, right? 1.5. So again, if this is 1 pi and this is 2 pi, then if I go 1.5 pi's, it would be down here, halfway between pi and 2 pi. So 3 pi over 2 would start here and go all the way to there, okay? So there's 3 pi over 2. Same thing as 270 degrees. Okay, they're one and the same. All right, and then 1/3 of pi, pi over 3. Okay, remember, pi is just halfway around the circle. So now we're going to cut this in thirds. So 1/3 pi would be about here, 2/3 pi would be about here, and then 3/3 pi would be pi. So 1/3 pi is 60 degrees. All right, think about, it's another way, let me go back and show you, but okay, here's pi over 3. So think about, okay, so it's a 60-degree angle. So think about pi is 180. So what's 1/3 of 180? So that would be 60 degrees. So pi over 3 is the same thing as 60 degrees. Okay. All right. So again, for a lot of you, this is new. And so the radians are hugely important. You have to know how to work with radians to do well in the chapters coming up with trig. So start learning them now. From today on, practice these radians and get used to converting a radian and a degree by just knowing the position of it, okay? Not using any formulas. Now, we do have a formula for that, but all right, then let's do the negative angles. Okay, so remember what these guys stood for. So negative 3 pi over 4, or 3 pi over 4, remember, was 135 degrees. So we're just going to go negative 135 degrees. So we would start here, and we would end up this way. Okay. Remember, again, if we went all the way to here, that's pi, negative pi. So 3 pi over 4 would be 3/4 of the way over. Okay, negative 3 pi over 2. That's 1.5 pi. So I would go over here to pi and then another half a pi. So I would end up here this time. So that's negative 270 degrees in degree mode. And then negative pi over 3, 60 degrees down. So we would go this way. So there's negative pi over 3. Okay. Now, there is a conversion, so that's next. So we'll practice that a little bit. You're welcome to use your calculator on these, but again, the more you know these and can see them for degree or radian mode right away, that's going to give you a whole bigger head start than if you have to do this all with a formula. So to convert from a degree to a radian, you would multiply the number by pi over 180. And to convert from a radian back to a degree, you do the opposite. You would multiply by 180 over pi. Okay? Now remember, for most problems, we're going to just leave pi in our answer. We don't want the decimal. We want the exact value, which means you're going to leave pi in there. Okay? So, number 7, we're going to take 135 degrees and convert it to a radian. So that means we're going to multiply this by pi over 180. So when you do this in your calculator, you're just going to put in 135 divided by 180. You can see that a little better. Don't put pi in your calculator. So we're just going to do 135 divided by 180. Hit enter. You'll get a decimal and then just switch it back to a fraction, math 1, 3/4. So we're going to write this as 3 pi over 4. Okay, I do not want the decimals. Unless the problem specifically says decimal, you have to give an exact answer, and exact answers have either radicals in them or pi in them. All right, so 330 degrees times pi over 180. So again, just take 330, divide it by 180, get your decimal, change it back to a fraction. So 11 pi over 6. Okay. Now remember, we did 3 pi over 4 already when we said it was 135 degrees, so that's the conversion. All right, now we have a radian, 5 pi over 6. So to change that to a degree, we're going to multiply by 180 over pi. Okay. If you have pi in both, top and bottom, you can cancel it. So then all we have to again do is 5 times 180 and then divide that by 6. So 150 degrees. Now, when you have degrees, you will always see the degree sign. If you don't see a degree sign, that's how you know it's a radian, okay? So if it's meant to be a degree, that little symbol has to be there. All right, 7 pi over 4, change that back to a degree, 180 over pi. So again, you got a pi in the top, pi in the bottom, they'll cancel out. So then we just have to do 7 times 180 and divide that by 4. 315. Okay. Now, look at the last one. Convert 3 radians to a degree. So even though it doesn't have pi in it, it's a radian. Okay, we already talked about where that was. It's right before pi, right? So we're still multiplying it by 180 over pi. So this time the pi's don't cancel. So we're just going to multiply 3 times 180. So that's 540 over pi. And it's fine to leave it like that. You could do the decimal if you wanted to. If you did the decimal, again, don't do it unless it says. So 540 divided by pi, which remember is second, the caret over here, pi. So 171.89, we'll round it. Degrees, okay? So again, that's not an exact answer. This is an exact answer, okay? All right. Okay, I'm going to stop there, and we'll pick up on the next part of the notes So we've hit our 30-minute mark, so we've only got a few more pages, but that last page I want to talk to you a little bit about, so we'll do that in part 2. Okay, so get to work on your homework, or if you want to finish your notes, then we'll move on to part 2. Have a good one.